All right, let's dive right in. Today, we're talking about something pretty mind-blowing, a story that stretches from the absolute smallest things in the universe, tiny quantum particles, all the way to the massive dusty plains of Mars. And the key to all of it? An incredibly short window of time. This is the 9-second cosmos.
Yeah, I know. It sounds kind of crazy, right? But that's the big question we're tackling. How in the world can a drop that's over before you can even tie your shoes, hold the secrets to, I don't know, building colonies on other planets, completely rewriting the laws of physics, and get this, even making our lives better right here at home? Okay, so let me introduce you to the hero of our story today. This is the ZARM Drop Tower over in Germany. And really, what you're looking at is a massive, super high-tech vacuum tube. It's about 146 meters tall. So what do they do with it? Well, scientists drop this special capsule down the inside. And for those 9 seconds while it's falling, everything in that capsule is in a state of almost perfect weightlessness. Now, I know what you're probably thinking. Wait a minute, don't we have the International Space Station for stuff like this? And yeah, you're totally right. But here's the real kicker. The ISS is, well, it's busy. You've got machines running, astronauts floating around, and all that creates these tiny vibrations. The ZARM Drop Tower, on the other hand, is just incredibly still. That means you can create one of the absolute purest microgravity environments anywhere on or off the planet. And that makes it the perfect spot for experiments that need to be super, super sensitive. So, the big question is, what can you actually do with just 9 seconds of perfect microgravity? Well, we're about to find out. First, we're going to look at some blueprints for Mars. Then we'll get into testing Einstein's ghost. After that, we'll figure out how to build a planet from scratch. And finally, we'll bring it all back home and see how this space stuff helps us right here on Earth. All right, first stop, Mars. It's one thing to talk about visiting the red planet, right? But it's a whole other ballgame to actually live there. So how do we make that leap from being just space tourists to becoming real Martian settlers? Believe it or not, the answer is taking shape inside one of those falling capsules. Think about the logistics for a second. It's just a complete nightmare. Trying to ship every single drop of water, every bite of food, every breath of oxygen, all the way from Earth to Mars, it's not just insanely expensive, it's not going to work long term. So the only real solution is to figure out how to live off the land, use what's already on Mars. So here's the incredibly smart solution they're testing out at SARM. They're taking these specific little microbes, cyanobacteria, and seeing if they can grow them in what is basically fake Martian dirt, or regolith as the scientists call it. And as the capsule drops, they watch to see how these tiny life forms can pull nitrogen and carbon right out of the Martian air and turn it into oxygen we can breathe and nutrients we can use for food and even medicine. It's basically a self-contained, self-sustaining life support system in a box. Just add Martian dirt and air. Okay, so we've been focused on one planet. Now I want you to zoom out with me. Way out, to the entire fabric of the cosmos. Because in that very same tower, scientists are basically chasing the ghost of Albert Einstein, putting the fundamental rules of our universe to the test. So what's at the heart of all this? It's something called Einstein's equivalence principle. It's a huge piece of his theory of general relativity, and the basic idea is pretty simple. Gravity affects everything the same way, no matter how heavy it is or not. So a feather and a hammer should fall at the same speed, right? Same for an atom and a whole planet. And for about 100 years, this idea has passed every single test. But what if there's a tiny, tiny little flaw, something we just haven't been able to measure until now? And this is where that perfectly still, pure microgravity at ZARM becomes absolutely crucial. Scientists do something that sounds like science fiction. They create what's called a Bose-Einstein condensate. They take a cloud of atoms and cool it down to just a fraction of a degree above absolute zero. The atoms basically mush together and start acting like one single giant quantum blob. Think of it like the most sensitive measuring tool you could ever imagine. Then, they drop two of these blobs, made from different kinds of atoms, and they measure with unbelievable precision whether gravity is pulling on them exactly the same. And you have to understand, the stakes here are, well, they're monumental. If they find even the tiniest little glitch in the data, just a whisper of a difference in how gravity treats those two blobs, that would be the first real crack in Einstein's theory in over a century. It could be the clue that finally leads us to a theory of everything, a single theory that connects the huge universe of stars and galaxies with the weird, tiny world of quantum physics.
All right, so from the far future of physics, let's jump in our time machine and go way, way back, like 4.5 billion years back. We're going to see how you build a planet, like our very own Earth, starting from, well, pretty much nothing but dust.
I mean, have you ever really thought about that? How does a big, fluffy cloud of dust in space turn into a solid, rocky planet? It sounds simple, but it's actually a really tough question to answer. So in the Drop Tower, what they do is basically create a tiny mini version of the early solar system. They just fill a capsule with different kinds of dust and minerals, let it drop, and watch what happens in that weightless environment. They get to see those first crucial moments where tiny particles start to stick together, to clump up, literally the first step in building a planet. And this isn't just about understanding ancient history either. This research has some very real, very practical uses right now. When you understand how dust and little pebbles act in super low gravity, you can design way better landers for missions that go to asteroids. You know, missions like Japan's Hayabusa 2 or NASA's OSIRIS-REx. These little 9-second experiments help make sure that a billion-dollar spacecraft actually lands on an asteroid instead of just booping it and bouncing off into space. Okay, so we've been to Mars, we've gone back to the beginning of the solar system. Now let's bring it all back home, because it turns out that all this really out there research has some amazing benefits for us right here on planet Earth.
You know, it's pretty wild. When you get rid of gravity, even something as basic as fire acts weird. Flames turn into these little spheres, they don't produce any soot, and they can burn at way lower temperatures. By studying these weird, cool flames in the Drop Tower, scientists have figured out things that are leading to way more efficient and cleaner car engines. Not only that, but also better fire suppression systems for planes and buildings. Even just watching how fuel sloshes around in a tank in microgravity has helped design better satellite fuel tanks, which means less space junk. It's amazing.
So let's just recap for a second. What do we get from a 9-second fall? Well, we're looking at tiny bioreactors that can make food and oxygen on Mars. We're talking about brand new kinds of sensors for exploring deep space. We get better data for mapping out how the universe began, and we get cleaner fuels and safer tech right here on Earth. I mean, when you think about it, the return on investment for just 9 seconds it's just staggering.
Really, when you get right down to it, the best way to think about this tower is as a kind of time machine. For 9 seconds at a time, scientists can jump into the future and see what it's like on Mars, or they can travel billions of years into the past to watch a planet being born. And they can even get a little peek behind the curtain at the fundamental rules that run the entire universe. And that really makes you wonder, doesn't it? I mean, if we can unlock all these cosmic secrets just by dropping something down a tube in Germany for 9 seconds, what other incredible discoveries are out there just waiting for us? Maybe not light years away in some other galaxy, but right here, maybe even hidden in plain sight. All we have to do is find a new way to look.